Welcome. I'm Director of Succinct. This is Margaret Palmer. This event, however, is organized not only by Succinct, but the Integrated Assessment Society, the International Environmental Modeling and Software Society, and the journal Socio-Environmental Systems. First of all, Dr. Sondoss Elsawah is an Associate Professor of Systems Engineering and Information Technology. She's also the Director of Capability of the Systems Center at the University of New South Wales. Our first panelist will be Dr. Juan C. Rocha, who is a research scientist at the Stockholm Resilience Center, where he co-leads the theme on complex systems. Dr. Renee Obringer is an assistant professor in the Department of Energy and Mineral Engineering at Penn State, as well as faculty associate in the Earth and Environmental Systems Institute. And our final panelist, Dr. Laura Schmitt-Olabisi, who's a professor in the Department of Community Sustainability and the Environmental Science and Policy Program at Michigan State University. And now we will turn to the video tutorial that will launch our series.
Welcome to this webcast on the use of systems thinking archetypes in socio-environmental modeling. I am Sondoss Elsawah. My research focuses on the design of multi-method methodologies to support socio-environmental technical modeling. In the 8 grand challenges for socio-environmental modeling paper, my co-authors and I identified critical needs for advancing CS modeling. Among those is the urgent need for methods to improve relevance and thus adoption of SES modeling and impacts on policy. In many situations, researchers, stakeholders, or decision makers may not be very interested in high accuracy computational results from modeling. Instead, they may be more interested in learning and communication of the insights that they could glean about the system. In such cases, they prefer methods that help in exploring the system's fundamental structure and how these components and processes influence the dynamic behavior of the system. This is especially true in situations, for example, where SES modeling is used to support social learning. That is, to bring different perspectives of a group together to build a shared and joint understanding of the problem. This is also the case when the interest is in the capacity building, or where stakeholders have limited technical knowledge, or there is limited quantitative data to support the effective development and use of computational SES models. Another related challenge we identified in the Grand Challenges paper is the need for SES modeling methods to consolidate knowledge from empirical findings and case studies. This is very important to accelerate knowledge building, and it opens the door for qualitative socio-environmental modeling methods that could be used in conjunction with or separately from quantitative SES models. One useful method for this is the very topic of this tutorial, namely system archetypes and how they can be used in SES modeling. This tutorial is organized into 4 parts. First, I will explain the concept of the system archetypes. What are they? Second, I will zoom in on 2 archetypes as illustrative examples. Next, I will highlight the interactions among the archetypes. Finally, I will present ways in which archetypes could be used to support SES modeling. Let's get started with introducing the concept of the archetypes. What words or images come to your mind when you hear the word archetype? Probably the word archetype may bring you a mental image of a pattern, a readily understood visual symbol such as those from ancient times, or perhaps a mental image of an idea, concept, or type of person. That is a typical example with a specific meaning. Archetypes can serve as exemplars or as representatives of system structure. And I mean by this the components and relationships that make the system. The term archetype is actually used in different research fields to refer to different things. But in this webcast, our focus is on the concept of archetypes as being theoretically grounded in system science. This is often referred to as system archetypes or systems thinking. The seminal work on system archetypes goes back to the popular Fifth Discipline book by Peter Senge, which illustrated systems thinking through the concept of the system archetypes. Simple yet very powerful examples that distill many of the systems at play in societies, organizations, and everyday life. System archetypes present classic stories about some of the most recurring complex problems. Each archetype tells a system story, which aims to crystallize specific system insights and help discern complex problem dynamics. Put simply by Senge, recurrent patterns of feedback loops in the system that produce similar dynamics. Researchers have discussed a number of system archetypes, but there are at least 10 that Senge identified have been focused on extensively. Familiar examples of these include archetypes such as fixes that backfire, which is meant to tell the story of unintended consequences, limits to growth, which involves the unanticipated system constraints, eroding goals, which depict the inadvertent poor performance, while accidental adversaries is about partners becoming enemies. As we will see by an example in this webcast, system archetypes are well understood and easily transferable across problem contexts. This makes them excellent tools for knowledge synthesis by providing a systems perspective. They provide learning insights about how a system functions, including, for example, interactions, feedback, and time delays. These interactions can be thought as causes and consequences that could inform policies. If these are not recognized, there may be unintended and many times undesirable consequences. System archetypes are visually represented as causal loop diagram. This is a well-known mapping technique, particularly in the field of systems dynamics modeling. See here an example of a simple causal loop diagram. A causal loop diagram is simply represented as nodes and arrows. Nodes are concepts or variables. The links or arrows are causal relationships. They show the direction of influence. Note, this is a balancing loop. The coping strategy may delay or reduce the level of job stress. Causal loop diagrams provide powerful visuals which help communicate complex ideas. System archetypes are particularly useful in learning about the interactions among social and environmental systems that cause problematic situations, because the diagram illuminates the fundamental structural causes of the problem, such as delays and feedback. Now, let's pick up a system archetype as an illustrative example of the insights that they could bring to such modeling. The archetype fixes that backfire occurs because people implement a solution, i.e. the quick fix, to reduce the problem symptoms in the short run. This is represented in the diagram as the control loop B1. The archetype suggests that while the quick fix provides solutions, it creates consequences that elevate the problem in the long run, as represented by the reinforcing loop R1. One could argue that all socio-environmental problems are demonstrations of the fixes that backfire, as we take short-term policy solutions. For example, drawing on groundwater stocks as a reactive policy for water scarcity could lead in the long term to more severe water scarcity crises. Another useful archetype is tragedy of commons, which is the crux of all overconsumption of finite natural resource problems. Tragedy of commons demonstrates how user groups claim their share of the commons, doing so to meet their own goals and objectives. They regard the commons as being uniquely available for their own purposes. As each group increases their demands and expectations of the commons in the name of their own goals, the pressure on the commons increases steadily, leading to collapse unless alternative courses of actions are taken. Each archetype embodies a theory about dynamic behavior of the system. In SES modeling, archetypes can serve as a starting point for collecting and formulating raw data into a coherent set of relationships. In participatory modeling situation, the use of the archetypes and the resulting behavior over time prompts the group to think about how factors that relate to each other and drive the dynamics of interest. For fixes that backfire, we show three interesting insights in the graph to the right of the causal loop diagram. First, the problem symptoms, the solid line, are reduced instantaneously in response to the application of the quick fix. This is the dynamics caused by the balancing loop, depicted on the causal loop diagram as B1. Second, the symptoms do not go away but keep coming back. In fact, the symptoms are elevated as shown by the upward trend. Third, the unintended consequences are amplified, an effect of the reinforcing loop depicted on the causal loop diagram as R1, causing more problem symptoms. The delay between the fix and the unintended consequences makes it difficult for the decision maker to link the cause and effect relationship and recognize that the fix is only worsening the situation. In some situations, the decision maker may be aware of the unintended consequence of the fix, but the delay may reduce the urgency to act or provoke, may adopt a worry about it later attitude. In these cases, this points out to deeper structural problems about decision cycles and responsibilities to act. It's valuable that each archetype is thoroughly documented in terms of the implications, when to combine short and long-term policies, and how proactively respond to side effects. For example, in the causal loop diagram depicting the tragedy of the commons archetype, you can see that actors involved in the situation undertake activities to increase their share of the common resource, driven by the gain that each actor could get. On doing this, they don't have information about the health of the resource and the impact of the resource degradation on their own gain over time. Working through these dynamics reveals insights. In this case, how communication and learning about the common resource and unsustainable use could change the decisions and behaviors of involved actors. The three elements of the archetype plus the dynamic behavior plus the policy implications and lessons make the archetype a very useful holistic tool for SES modeling. This brings us to the third part of the tutorial, interactions. Archetypes are not meant to be used in isolation. There are many ways in which the archetypes can interact with each other. By this I mean recurrent pattern of feedback loops are often associated with or linked to other patterns of feedback loops. Michael Goodman and Art Kleiner have mapped 10 archetypes and their interactions. They focused on business organizational contexts, and so the map showed the interlinked management problems that occur repeatedly in the corresponding archetypes. The intent is to show that archetypes could provide a structured thinking process or a roadmap to untangle a complex problem and reason about effective courses of action. The same archetype associations occur for socio-environmental problems, and in SES modeling, recognizing that an observed feedback pattern is often associated with another common feedback loop provide the basis for a conversation among the modeler and stakeholders about the nature of issues they face and the dynamics of interest. For example, fixes that fail dynamics often leads to shifting the burden dynamic and a gross but underinvestment behavior often leads to eroding goal dynamics. This brings me to the last part of this webcast, where I'm going to share with you ways in which systems archetypes could be used to support SES modeling. Turns out there are multiple ways to use archetypes throughout the socio-environmental modeling process. First, in the stage of problem identification, where the archetypes can be applied as a diagnostic tool. Archetypes are effective for beginning to answer questions such as, why do we keep seeing the same problems over time? And what can we do to overcome these problems? Using archetypes is similar to trying on different lenses to examine problems, which can lead to asking provocative questions and may lead to productive conversations. Trying on different lenses is a reminder that there are multiple perspectives and views for interpreting the situation. For example, Bahri 2022 used a set of archetypes to examine the system drivers in the water, energy, food, and land nexus in Indonesia. The author focused on a reservoir that generates energy but also provides water for households, industry, and irrigation. The author found that system archetypes were very useful for studying the system of system level interactions and resulting dynamics that lead to the problem. So rather than focusing on systems such as land, water, energy separately, the author focused their attention to the interactions and on the dynamics resulting from the interfaces among nexus systems. The author commented that because of the archetypes, they were able to reveal the key problem components and relationships that provides the basis for the development of a simulation model. In another example, Regina Nudred and colleagues focused on pastoral socio-environmental systems trapped in degraded states. Were there negative feedback loops keeping these systems in that state? They used archetypes analysis to identify interlinked management problems that occur repeatedly across cases. Three system archetypes, the tragedy of commons, shifting the burden, and the success to the successful, were used to analyze data and identify the key variables and relationships that trigger the overuse of pasture. Another use is to apply the archetype as prospective thinking tool. Archetypes are effective tools for beginning to answer the questions, how can we avoid falling to these problems? And how can we shape our future to achieve desirable outcomes? This is particularly useful when generating options and strategies for evaluation of problems through SES modeling. A variety of strategies can be tested through the lens of archetypes to identify potential pitfalls and address them in the planning stages when they are easier to tackle. System archetypes provide a language to communicate among stakeholders regarding how a particular strategy is expected to perform. For example, Moalmi et al. Applied archetypes to the context of examining interactions and trade-offs associated with implementing the Sustainable Development Goals. Using the 8 archetypes in an analysis, they were able to generate insights into the potential desirable and undesirable dynamics that result from a piecemeal approach to the implementation of the SDG policies. The authors used the archetypes to develop a typology of interactions that can serve as a framework for knowledge synthesis from a large number of empirical findings, compiled through different methods and from many case study applications. This also demonstrates that archetypes are useful as synthesis method to consolidate results across different SES modeling case studies to help reveal options or facilitate policy development. In another example, Zar et al. 2017 used archetypes to analyze water scarcity issues and propose management interventions to change the recurring dynamics. They found that the overall dynamics of a water problem could be explained using 4 archetypes. This archetype analysis was used in a follow-up paper in which a multi-method SES modeling process was employed to develop a simulation model. In that paper, authors combined the well-known conceptual modeling framework called DIPSR with system archetypes to develop a quantitative system dynamic simulation model. Before I bring this tutorial to a close, a few words of caution. Like any problem-solving method, the system archetypes could be abused if not used for the right purpose. First is to be mindful not to predetermine a right archetype for a situation that would be imposing a structure on the problem. Archetypes shouldn't be used as templates to force-feed problems and narrow the way we view problems. On the opposite, archetypes are intended to serve as systemic lenses to help us understand the problem from multiple perspectives and angles. One safeguard against the risk of force-fitting is to try as many archetypes as possible to look at the problem and identify useful storylines and lessons to be gained about the situation. Second, the use of the archetypes should be supported by evidence from data, qualitative, quantitative, or both, in order to substantiate claims and implications and avoid making wrong speculations about the problem. Okay, now let's quickly review what we have covered. Why are systems archetypes useful for socio-environmental problems? We may know we have problems, but don't understand the nature of these problems. Here, system archetypes can serve as the lens to help us identify possible problem framings. We may have identified several issues, but we lack a focus on the heart of the problem. Here, system archetypes can help us distinguish and analyze relationships, and even provide guidance on what data to collect. We may be concerned about the future problems and wonder what could we do to avoid them. System archetypes can be used for prospective thinking to generate scenarios and proactive steps. We may know how the problem works, but not what we can do about it. Here, system archetypes provide insights into the short and long-term policy and planning to overcome the dynamics. Socio-environmental problems are difficult, so any tools we can bring to help us understand and solve them are valuable and much needed. Certainly, system archetypes are one of those. I hope you have enjoyed the tutorial.
Thank you very much, Sondoss, for that outstanding delivery of the tutorial we provide. And yes, this will be available. We'll have the tutorial fairly quickly because it's great for use in classes and to introduce the topic to others. We're going to see if there are any questions that Sondoss can answer. Caroline, were there questions?
We have one compliment to begin with. The presentation, Sondoss, was fantastic. And this person is interested in the references. Will there be a bibliography of these references after the presentation or once we publish the recording? And
yes, so we could provide this list after the webcast.
So now I'm going to turn to Juan Rocha, who will now give his presentation.
Super, thank you. If you have to remember only one message from my talk is this one: comparison is key for archetype discovery. In the interest of time, I'll be passing slides a bit quick, but they are available on my website on that URL. And all the text in blue are active links that you can click and go to the papers that I'm mentioning in case you're interested. Thanks to the previous speakers and the nice introduction of Sondoss, I can just go through this very quickly, but archetypes When I think of archetypes, I think of Lego blocks or building blocks. This is the definition from the Oxford Dictionary. They refer to typical examples, prototype, primitives, or motifs in literature, but you can always interpret them as building blocks. And that interpretation, I think, comes from Jay Forrester, who was an engineer, a professor at MIT, who was heavily involved in the development of the World Tree model, and he was part of the Club of Rome. He was also a mentor of Dennis and Donella Meadows and their pioneering work on system dynamics and the limits to growth. In the words of Forrester, he believed that there was a set of genetic structure, perhaps max 20 or something like that, that would be able to summarize most of the policy issues that managers encounter on the ground. By genetic structures, he was thinking of these causal diagrams that you have seen over the talk, but he came with a background from engineering. So these causal stories could be either narratives. Those narratives could be interpreted as equations that produce some behavior, like this example on the slide, or they can be these diagrams that synthesize some of these iconic behaviors. These are 4 problem archetypes with the 4 solution archetypes on the next slides. To complement what previous people have said, these diagrams are excellent for communication, but they have some limitations. They obscure accumulation processes, delays, and it's very hard to infer dynamics just by the picture of these little networks. If you're interested in discussions on the pros and cons of that literature, the references are there. What I want to convince you at the end of my 5 minutes is that these structures correspond to 2 sides of the same coin. On one side, you have the structure that can be represented as a narrative that comes from a participatory process, for example, a set of equations that someone is trying to model on a computer, or these iconic networks of causal diagrams. And on the other, you have the behavior of the system. That behavior could be a simulation of the computer or some observations on the real world about the statistical signature that this socio-ecological system leaves on data. Since there are 2 sides of the same coin, you can try to understand them from the 2 different perspectives. I will present 2 papers very quickly where we do exactly that. On the reference below, we use causal diagrams to understand common drivers and common causal pathways between systems. The reference from 2019 is looking at 7 different case studies where we were interested in what causes land use and land cover change in Latin America. We developed these causal diagrams based on expert elicitation and literature review. And then with the 7 cases, we were able to compare and smash all these little causal diagrams in one big network. On that big network, then you can use something like a structural equivalence to figure out what are the common drivers and common causal pathways across cases. Thanks to that analysis, we found that deforestation, threat, technology, food demand, and commodity prices were some of the common causes across all case studies. We also map out some unintended consequences of policies. For example, in Uruguay, there were policies to incentivize soy development and disincentivize cattle ranching. And they work out, but the cows didn't disappear in space. They moved towards Paraguay, where the cattle ranching expanded, and we did the deforestation frontier there, what we call leakage effects. We believe that this qualitative work can complement the more data-driven stories or the data-driven work. On the other side of the coin, from patterns to structure, this is a paper where we studied the Volta River Basin. There's a big river that crosses the landscapes of Ghana and Burkina Faso. And then this is a landscape that is characterized by drought and very difficult to grow foods. We were lucky to have a time series on some of the crop productions, which is the graph on the right that you see, but the data was characterized by a lot of missing values and incompleteness, which is all that orange area in the graph. We were inspired by the work of Elinor Ostrom, who developed a framework to study social ecological systems. And what we did was taking the first and second tier of variables that she proposed, and then trying to match variables from these public available data sets that match some of these social ecological systems frameworks. So we use the crops, for example, to represent interactions. We use a variable like number of cattle, small ruminants, or dams to represent the resources that farmers have to deal with drought and produce food. We use a variable like migration, regional, external, population trends, and market access to describe the social domain. We use a number of farmers, literacy ratio of women and children to describe things like the type of users. And the ecological sphere were described by things like aridity, soil, water moisture, the slope of the soils, and so forth. By using that dataset, then we ran a number of clustering techniques that allow us to identify groups that share certain similarities on those time series and that census data. The map on the left is the final result, where we identify 6 different archetypes or clusters, and then we can start studying what makes them different. So, for example, the green cluster far north is the one that has higher aridity, while the blue and yellow and red are the ones with less aridity, and so forth. So we can go variable by variable, group by group, and study what makes them different. I think what makes this paper stand out is that many papers in the past have been using these clustering methods to identify groups, clustering ecosystem services, finding archetypes of land use change, anthrops, you name it. But what the other papers have not done yet is performing a sensitivity analysis that allows you to identify what is the right number of clusters to fit and what is the best technique to fit those clusters. The problem is, if someone fits something in Canada, I cannot assume as a Colombian that particular method will work well on my data, on my Colombian data. So what we did was doing the sensitivity analysis across over 30 different metrics of performance and across about 10 different ways of clustering or algorithms that we can apply to it. That gave us more confidence, and the number of clusters was 6 indeed, and under different algorithms we were finding about the same results. So we were able also to compare metrics of performance of the clustering technique. We then were able to ask questions where for example, investments of dams were going to help farmers to deal or increase resilience to droughts or deal with variability on crop production. We were not able to find out causal effects. I can tell you that on the questions section. But then it has to do with a little bit of the limitations of these methods. So if you go from structures to patterns, you will be facing challenges whether you have, for example, the same semantic coherence. If you're doing a participatory method and people are talking about rain, some people might be referring to the change in the mean, while others might be referring to the change on the variance. And those nuances on the language are difficult to translate to the causal diagrams or the equations. If you're going for patterns to structure, then you will be limited by the scale of data availability, and you will be prone to overfitting or error propagation. And because of that, these sensitivity methods are very important. You will also be limited in terms of identifying the causal effects or the feedbacks, the interactions, when you are coming with a data-driven method and the data doesn't allow to statistically test out for that. With that, I would like to close by emphasizing that leverage comparison can enable archetype discovery. That's the key message of the talk. You can use causal structures and compare them with something like a structural equivalence if you transform that causal structure on a network form. You can also study recurrent patterns in space and time and use clustering methods to figure out what are those building blocks or the types of social ecological systems out there. I didn't talk about QCA, but that's another qualitative method. It's called qualitative comparative analysis, and it's another way to try to gain a support for causal recipes. So what type of features are necessary and sufficient for some output to come out? There is a recent reference there that also explored that avenue. But I would like to close by saying that there is limitations of any of those methods. So I would recommend to have a multi-method approach. If you are doing some theoretical work, trying to ground that with data, and if you are going from a data-driven perspective, try to choose your variables and motivate your analysis on well-grounded theory, which in our case was Ostrom legacy. With that, I would like to say thank you and pass on to the next speaker.
Thank you very much, Juan, for that excellent presentation. I also might alert our audience to the fact that on Succinct's website, we have an explainer on archetype analysis, and it covers some of, in just very brief, introduces many of the topics Juan touched on, like how to use statistical methods and other ways for identifying archetypes. Renee, why don't you go ahead and launch your presentation now?
So we'll just move along. My brief presentation is about a case study where we leveraged self-organized maps, and specifically we're trying to create archetypes of water conservation attitudes as a way to possibly develop more successful interventions in terms of demand management. So this research was done as part of my postdoctoral fellowship at Succinct, and it focuses on the Southwest United States. So we've got 3 cities, Las Vegas, Denver, and Phoenix. And prior to my postdoc, my collaborator, Dr. Dave White at Arizona State, conducted a mail-based survey across these 3 cities, got about 3,000 respondents, pretty equally distributed across the city, 3 cities. And so that original study was focused on climate change and drought and water consumption. And so we leveraged a few of these study questions to develop these archetypes using, as I mentioned, self-organized maps. And if anyone has any questions about that, we can answer them later after the presentation. But I really wanted to focus most of this short talk on the actual results and the actual archetypes. Because what we're seeing here is we developed 7 key archetypes, and we use these radar plots to show the answers to these survey questions. So question 1 here is about management in government agencies of water. Question 2, A through F, is all about different types of demand management strategies, ranging from reusing wastewater to government mandates on reductions. 5A is about climate change beliefs in general. And questions 6, A and B, are about personal responsibility or personal knowledge of water resources conservation. And 7A is about the actual responsibility to participate. And then 8 and 9 are about demand management plans at multiple levels. And so we named these archetypes different things. And our plan with this goal, with this study, was to really try to make these more descriptive than just, describing, archetype 1, archetype 2, and tried to focus on how the members of these archetypes will behave and how they view water conservation efforts. And so our first archetype over here, we called the would-be participant. And this archetype really gets sort of paired with the orange archetype down here, which we called the participant. And we call these, they're sort of very similar. They have very favorable views. So the further out on the radar plot, the higher the Likert scale, so 1 to 5, 5 being strongly agree. And so we see that both of these archetypes, on average, have very favorable views of a lot of demand management plans. They have favorable views on climate change and the impact of climate change in their communities. Where they differ is these 6A and 6B, which, as I mentioned, are these personal knowledge questions, whereas 7A are these personal responsibility. And what makes these 2 archetypes very interesting is that the participants recognize that they have a strong personal responsibility for conserving water, and they rate their personal knowledge as very, very high. They know what to do. They're very likely actively participating in these programs within their local communities. The would-be participants have a similar personal responsibility, but they rate their personal knowledge as fairly low. And why we call these the would-be participants is they represent a group of people that would likely be very accepting of a demand management program in their local community. They just need to be told about it. They need to be educated about what they can do and how they can help. So this represents a subset of people that can be targeted, so to speak, through a demand management program to really start to encourage and bring those community values from the ground up. Briefly, through some of these other archetypes, we have an individualist who feels very strongly about personal responsibility. They have fairly high rankings of personal responsibility, but they have a somewhat negative or somewhat disagreeing view of the government's responsibility. So these are people that maybe view it as individuals conserving, and they don't necessarily see government agencies coming top down as that part of their role. We also have a concerned group, which is very concerned and very favorable towards these top-down government programs, but they have very low rankings on personal knowledge and personal responsibility. So maybe this is the type of person that recognizes there's a problem, they expect the government to fix it, and they don't see that as sort of an individual effort. And then we have a neutral archetype that's sort of just in the middle of all of them. We have a confident denier, who is very interesting. They have very high rankings on personal knowledge, but very low rankings on the acknowledgement that there is a problem. So they're very confident in solving a problem, less so in believing there actually is a problem. And then we have a disengaged group. And this is just a group that doesn't seem to recognize some of the programs going on. Maybe they're new to the area, maybe they aren't very involved in water demand management in general. So these were the archetypes that we came up with. And one of the things we wanted to do with this project is kind of look at how these archetypes actually function within the city. So our first step was to just look at the distribution to see how they actually separate. And so here we can see that, our would-be participant is fairly active across all 3 cities, whereas, some good news, the confident deniers are fairly low percentage of our survey respondents that are relatively representative, but could be better, certainly as far as surveys go. So with that, thank you for attending. This is the paper that we published, and this QR code will leave you here. So I can always bring up this slide later if you guys are interested.
Thank you very much, Renee, for the excellent presentation. We look forward to some Q&A following all of the panelists, and then we'll bring you back. Laura, would you like to share your slides now and begin speaking?
Great. Thank you, Margaret. Thanks, Sondoss, for that excellent introduction. It's really fun to be here with all of you interested in archetypes, really some well-known names and a large audience on the webinar today, so that's exciting. So today I'm going to talk about how we used archetypes in a project that we have been doing in Flint, Michigan for the last 4 years. We're now in the 5th year of this project. It's called the Flint Leverage Points Project. And I'm going to give, I know this is an international audience that may not be familiar with the situation in Flint, so I'm going to give a brief background on the situation there. So Flint is a city that in 2014, an emergency manager, who was a person appointed by the, at the time, governor, and was not democratically elected, decided to switch the water source for the city from the Detroit water source to the Flint River. And in the process of doing that, the city did not add appropriate anti-corrosion chemicals to the water, and loading the lead pipe infrastructure in the city that was part of many people's home water source, and creating a massive lead poisoning event, including thousands of households were affected, and many of them had children living in them. So compounding that was the fact that residents were complaining about this right away, but their concerns were not taken seriously until an outside expert from Washington, D.C. came in, from Virginia Tech came in, and was testing the water and found that there was lead poisoning going on. So why, this is the background of, the project that we entered into. So there's 2 relevant things for this from the Flint water crisis. One is that this opened up a massive distrust between the residents and the state government, scientists particularly, very understandably so, because their concerns were dismissed and ignored by those people. And secondly, it created a health crisis in the city. And the food system is directly related to that, because when you have a lead poisoning event, having access to healthy and nutritious food can help to abate the impacts of lead on the body. If you have adequate nutrition in your diet, it helps keep that lead kind of locked in your bones and not circulating in your bloodstream. So the fact that Flint did not have a highly nutritious and equitable food system was compounding the problem of the water crisis. So that's the issue that we partnered with the Community Foundation of Greater Flint to try to address in building a systems model of the Flint food system. And so one of the ways that we did that is that we interviewed more than 200 people about the Flint food system and their experience of it. So these ranged from people who are, households and consumers from different parts of the city, from different backgrounds and constituencies, to folks that have a, kind of a broader role or decision-making role within the food system, like folks who run food banks or folks who are working in the mayor's office and things like that. And we used archetypes for communicating between the daily experience of the people who are experiencing the system and the modelers who are representing it for the purpose of finding leverage points to shift the system, right? And so the reason we did that is we have encountered some pushback on, the use of causal loop diagrams with folks who are not familiar with modeling tools. We've heard them derogatorily kind of called spaghetti diagrams. They're confusing. They're very useful as systems modelers. We still use them, of course, but archetypes are an easier way to kind of communicate back and forth and to diagnose systems problems, as Sondoss said. So I was showing an example of this quotation from one of our interviewees in Flint, who was describing a situation in which, the food donations and monetary donations that came into Flint in the wake of the water crisis and the pandemic were supporting a food infrastructure that was helping to feed people in need, but at the same time kind of undermining the ability of the food system in the city to feed itself. And so we identified that as a shifting the burden or an addiction archetype, in which you have, the problem symptom, which is the need for food. You have hungry people, and you have free produce that is coming in as a kind of Band-Aid solution, but it's actually undermining the core system's ability to grow and distribute food in a sustainable way. So that's just one example of how we coded archetypes based on interviews with people. And we identified more than 200 archetypes interviews, but many of them were kind of talking about the same thing. So it's not really 200 unique archetypes, it's 200 examples from the interviews. And so what these allowed us to do was to move into policy implications, because one of the wonderful things about the archetypes is that they describe the system behavior and then they describe kind of intervention points, right? And that's exactly what we were looking for in this project, is intervention points to shift the Flint food system into a more desirable trajectory. And so this particular archetype, the shifting the burden one, we worked with Flint stakeholders to come up with scenarios by which we could disrupt that, right? And so these are some of the solutions that they proposed: shifting some of the money coming in from outside donations from the emergency sector to rather supporting local growers, supporting local producers, moving into a cooperative food retail model in which the community kind of owns the food retail. Employment opportunities and getting people involved in the food system as employment opportunities, and then addressing structural poverty. Of course, that's not a short-term or simple thing to do, but that's really the part of strengthening the underlying system that's going to eventually remove the need for emergency food aid. And so one of the cool things that we're trying to do in this final year is work with local artists from Flint to actually put up, some of these archetypes in art form around the city. And so the person in the middle of this photo is actually our project manager in Flint, and he manages a community art program working with Flint muralists. And they've done a number of beautiful murals around the city. So we're looking forward to that. And so, some lessons that we've learned from this application of archetypes to a participatory modeling problem in Flint, we have found that they are better at communicating back and forth between modelers and community partners, better than, the kind of causal loop diagrams that some people derogatorily term spaghetti diagrams. I still love CLDs, still use them, but, they're hard to use sometimes. And then another thing that we learned is that the interviews should really be done by a team of systems modelers. We outsource some of that to other qualitative folks on our team, and I think sometimes they didn't do as well at eliciting, the full archetype. And then, the identification of these systems change paradigms requires deep coordination and capacity building. Okay, let me stop there.
Thank you very much, Laura, for that. We appreciate that. Now you can close your presentation, and I'd like to invite all of the panelists to turn on their camera. And then I'm going to ask Caroline to address questions to various panelists. And then, of course, the panelists are welcome to ask each other questions. Caroline.
The first question is directed at all of the panelists. So the assumption is that system dynamics are based on deterministic reasoning. How does one make sense of deterministic reasoning in socio-ecological systems where agency of actors plays a key role in determining system behavior? Do any of you want to launch into responding to that question?
I can have a start.
Thank you.
So I think in systems dynamics, the purpose of the or the lens that systems dynamics take is a macro systems view, and I'm assuming that the deterministic reasoning here, you mean that we are assuming that those actors are don't have free will. They are really have all the decisions that they are making are influenced by other factors. I think we don't really make this decision in systems dynamics. The purpose is to understand what really drives the decision rules. Actually, we take a lot of interest in unpacking what these decision rules are, what influence those decision rules, how if we change the system structure, this will lead to the different decision rules and behavior. So I don't think we assume entirely that people don't have agency, but we are interested to take one step backward and try to unpack what drives these decisions and how we could influence it. But if you're interested more of focus on the individuals and the agents' view of the system, then maybe systems dynamics is not the best approach. Something like agent-based modeling could be more suitable. It depends really on the purpose of what you are trying to achieve when you are studying the agency of the actors in the system. So over to Juan. I see he's has something to add.
Thanks, Sondoss. No, my answer was very similar to yours. I don't think there is to me, there is a continuous between systems dynamics or ordinary differential equations and agent-based modeling. There is not a divide there. It depends on your research question and what you're trying to answer. If your problem is defined by strong components of heterogeneity, where you have different types of agents with different abilities to interact with each other and with their environment, there's something like an ABM is the tool to address that problem. But even in differential equations, there is agency there. The problem is, or the thing is, we're assuming that the agency of all the components are the same and we can ignore it. That's the mean field assumption. But if you have a very simple ordinary differential equations with a network on it, where say Sondoss, Caroline, and I are connected, but we're not connected to Renee and Laura, then that little heterogeneity there put us in a slightly different position to influence the overall dynamics. So already adding an adjacency matrix, a network, a social network, to your very simple dynamical system changes the agency of the elements of that network, whatever they represent, social or ecological actors.
Thanks to both of you. Renee, I don't know if you want to add to that, but there are two questions coming up that are directed to you, so we can also move on to those.
Yeah, we can go ahead and move on.
All right, Renee, super interesting. Thank you for sharing your great research. The participant is not sure how you used Likert scores on a radical plot to infer interactions and dynamics between factors. Since structure drives behavior within an archetype, these interactions are really important to elucidate. Could you translate these archetype stories to corresponding structures, or have you already? Questions there?
a really good question. So to briefly talk about sort of how the radial plots work, we have 3,000 survey responses, and each of those survey responses has 14 questions, and each of those 14 questions was on a 1 to 5 Likert scale. So we used the self-organized maps paired with a hierarchical clustering algorithm to develop these 7 clusters of respondents who were similar enough. And we went through several sensitivity analyses, such as what Juan talked about, to sort of make sure that these 7 clusters were the optimal number of clusters. And so the radial plots are actually showing the average response within a cluster from 1 to 5. And so they're not necessarily getting at any driving behavior or structure, just that people in this cluster tend to strongly agree that climate change is a problem that is affecting their community and their families. And so based off of that, and based off of some of the previous literature that has dug into attitudes and intentions and behaviors, we started to get a descriptive analysis of what that type of person, what that respondent who is part of that archetype, why they are possibly the way they are, and what those might mean in terms of a water conservation program. And so that was where we stopped with this particular project. And then going forward, we're actually trying to integrate this into an agent-based model so that we can start to get at some of those driving behaviors and some of those interactions. So we're building up these agents. Each of them is part of a cluster or an archetype that is using water. And if we change their archetypes, if we actually integrate some policy, do we actually see any significant change to their behavior within this agent-based model? And so to answer your question, we haven't quite gotten there, but that is sort of the ultimate goal, to develop some, to actually use this in a more practical sense.
Can you talk about how transferable your archetypes may be to other places or problems? This was directed at you, Renee.
Sure. We think that it's fairly transferable to other cities within the Southwest US. Since we did include the 3 cities, these archetypes are present throughout all of them, and so we think it's transferable. We haven't looked into other places, but our aim with using the self-organized maps and data analytics approach is that the method could be then applied to other locations if the survey data was available.
So how do archetype methods account for the socio-environmental impact of the use of technical interventions, such as data analysis that may have underlying complex interdependencies in a socio-technical ecological system?
The archetype is a method, and if I understand the intent of the question is, if we would like to better understand the impact of some technological interventions on the system, would archetype be used in this capacity? Absolutely. We could start using it as a thinking aid or a tool of conversation among stakeholders to answer the question, are there any unintended consequences that could come from using this particular technical interventions, and use the archetype as a thinking tool to tease this type of consequences. So absolutely, it could be used in this way. Whether we will end up with a coherent story about which falls under one of those archetypes, that's another question. But it could definitely be an inquiry, open the inquiry of thinking around those unintended consequences.
Okay, thank you. Anyone else want to add to what Sondoss has said? Yes.
I can complement with 2 comments. First, I would like to flip back the question, not in terms of the interventions, but if you are doing something like a randomized control trial, let's assume you have all the money, all the resources. In order to identify a causal effect on that setting, you need to identify a control group and a treatment group that otherwise are comparable, right? That exists for medicine, economics, that type of discipline, but for social ecological systems, we don't have those units that are similar but comparable when you have a treatment versus control. So these archetypes allows you to identify those towns or districts that share social and ecological features, and that could be comparable once you implement a policy on, say, a side of the border where something is applied versus a side where it's not applied. In that way, you can identify causal effects of interventions, as your question is there. Now, for my study in Volta, in the Volta Basin, Ghana and Burkina Faso, we failed on that for two reasons. We didn't have enough data to be able to test the causal effect of the implementation of dams as an intervention. And second, we did not have data on the use of fertilizers. So a confounding variable that even if we could run a regression, the lack of that confounding variable make our regression not being interpretable as a causal effect. So the archetypes only takes you so far. They only gives you the treatment versus control and what could be compared. But if you are missing that additional information on mediators, then you won't be able to disentangle the effects of interventions.
Okay, thank you very much, Juan, for elaborating on that. Any other comments from anyone else on that particular question? Otherwise, we can move on. What was the structural equivalence method you used to parse out the core archetypes from the aggregated system that you presented in your 2019 study?
So both in that study, the case studies were summarized as a network, and then I was able to put all those networks together on a big network. On that network, that matrix, you can calculate the distance. Since it's a causal diagram, you will have plus one for positive links, -1 for negative links. But if your method allows to do some clever weighting, like the case where Renee presented, you can also do it with a weighted network. And what you do is you calculate a distance. In my case, I think it was Jakar because it's binary, but you could do an Euclidean distance or something like that and do hierarchical clustering on that distance matrix. That gives you variables that are very close in that metric space because they are connected to similar things and performing similar roles on that network. So that way we identify drivers that always are together or kind of operates on the same way, or causal pathways that were common across different case studies. But statistically, it's a distance matrix with a hierarchical or some sort of clustering, a dendrogram on the top that allows you to sort out common pathways on that network.
Okay, thank you. Thank you for that, Juan. Now, a general question to the panel. The attendee thanks everyone for their interesting presentations, but does not quite understand what the difference is between archetypes and typologies. And I think perhaps we'll begin with Sondoss to respond to that question.
Yeah, I think the way we use archetypes in this particular tutorial, it is the systems archetypes. It is this particular 10 or 11 ways of capturing cause and effect relationships and learning about the system feedback loops and delays. I think the word typology is bigger than the system archetypes. It's about categorization and different fields and different interpretation of what a typology is. So I think if we can narrow the context of the tutorial is to the systems thinking archetypes, this will help perhaps differentiate between archetypes and the broader definitions of typologies.
Yeah, and I think that Laura would back you up there. She's written in the chat that very, very simply, archetypes speak to dynamic system behavior.
Yeah, exactly. Yeah, I was just, I think Sondoss said it. Yeah, we're talking about systems archetypes here, and what they, with typologies, you can't necessarily predict the behavior of the system, right? But archetypes allow us to do that. So that's maybe one of the key differences. But you could see archetypes as a type of typology or a particular type of typology, I guess, a specialized one.
Okay, thank you. Thank you, Laura. I think that I've reached the end of the queue questions in any case, and there are some references and additional information from our very active participants in the chat. So that will also be recorded, and so you'll be able to see those references as well. Okay, thank you. Margaret?
Thank you. Thank you very much, Caroline. And I really want to thank our panelists, Renee Obringer, Juan Rocha, Laura Schmitt-Olabisi, and Sondoss Elsawah for great presentations, and our audience for lots of good questions. The recording, the tutorial will be ready very quickly and for anyone to use, and the panelists' comments combined will be ready within several weeks, as well as the references that were referred to. Thank you, everyone, and have a great rest of the day or start of the day.
Thank you all.
Thanks, Margaret. Bye-bye, everyone. Thank you.
Bye, everyone. Thanks.